This lesson is on section 12.2, chords and arcs. It's an introduction to segments and pieces that are individual in each circle. The first definition we're going to talk about is what is a chord. A chord is simply a segment that starts and ends on the circle. Okay, in the last lesson we talked about tangents. Tangents were lines that just skimmed the edge of the circle. Chords actually start and stop on the edges of the circle itself. There's some relationships here. These all get kind of jumbled, but you'll see as we go through that they make more sense. If you have congruent chords, so if you have two chords in a circle that are equal to each other, then the angles that go out to those, if I were to draw the angles that go out to those edges of the chords, in other words, this angle and this angle, they would have to be congruent to each other. And you can see that they would end up being vertical angles anyway, so you would know that they're congruent, but that's just one of those key things. So if you draw the central angles that make up those chords, those two angles will be equal to each other. Since the angles are equal to each other, the arcs are also equal to each other. So not only are the angles equal to each other, the chords would be equal to each other, and the arcs would be equal to each other. All of those things, if one of those holds true, then all three of those things hold true. So they all go together. It's a package deal. If the angles are equal, then so are the chords and so are the arcs. If the arcs are equal, then so are the chords and so are the angles. They all go together. That's what this says. There are two other theorems that we are going to talk about. One says that if your chords are congruent, that they're also the same distance from the center of the circle. So if you draw a line and we decide that by using a perpendicular line. So if we draw a perpendicular line to this one and a perpendicular line to this one, if the chords are equal, then this distance, we'll call it D, would have to be the same as the distance here. They are the same distance from the center of the circle. That's one characteristic. The other characteristic is that just the opposite of this, that if you know that the distances are the same, then the chords have to be equal. These are converses of each other. One goes one way, one goes the other. So this distance is equal to this distance if the chords are congruent, and if the chords are congruent, then this distance has to be equal to this distance. This one, there we go. All right, the last thing that we're going to talk about is called the radius and chord theorem. It's the relationship between the radius drawn in a circle and a chord drawn in a circle. It says if you draw a radius so that it is perpendicular, so that it makes a 90-degree angle with the chord, that it bisects the chord. So if there's a 90-degree angle here, then the distance from A to X would have to be the same as the distance from X to B. And it goes both ways. So if you know this distance is equal to this distance, then that has to be a right angle. Okay? So a radius drawn to a chord, if it's drawn at a 90-degree angle, it will create equal parts in the chord. AX would be equal to XB. Some examples that we're going to look at are that notice what they have in this picture, that the distance from C to D is 4 and the distance from C to R is 4. They give us that the length from Q to R is 7, and they give us that the measure of the arc QS is 100. And they ask us to find some of the following measurements. Okay, so let's start with RS, the distance from R to S. Well, since our radius comes down at 90 degrees, we know it bisects the chord. So we would know that from R to S would have to be 7. Then we go on to AB. AB is a chord. it is the same distance from the center as chord QS, so it would have to be the same length as QS. So AB would have to be 14. Arc AB, this leads us back to the first thing we talked about. Arc AB would have to be the same measure as arc QS. Since the chords are equal, the arcs will be equal. So the arc AB would be 100. And then to find CS, CS is the actual length of the radius. In order to find that, we would do the Pythagorean theorem. 4 squared plus 7 squared equals x squared. Okay? So I set that up somewhat. So we would do 4 squared plus 7 squared equals the distance from C to S squared. We would then say we would add 4 squared and 7 squared and get 65, and then we would have to square root 65 to get the length from C to S is 8.06. That's one good way to find the length of the radius if you don't have it. The other example problem that we are going to look at is, it says in circle P has a radius of 5. Okay, so that means from the center out to the edge is 5. It says if PR is perpendicular to AB, so we know that this is a 90-degree angle. They want us to find the measure of A to B. Okay, well, let's start with knowing that the radius is 5. That means anywhere I draw in, that radius is going to be 5. If I draw it in the right spot, it will make the most sense. All we're given is that from P to X is 3. But if I can create a right triangle with this right angle, and I know that that's a radius, so it would be 5, I've now created a right triangle of which I know 2 sides. So I can find the third side by using the Pythagorean theorem. So I would set up 3 squared plus x squared equals 5 squared. Now remember, my ultimate goal is to find the length of AB. So if I can find the length from B to X, and this is a 90-degree angle, I know that all I have to do is double it to get the length of AB. So I would do 3 squared plus x squared equals 5 squared. Three squared plus x squared equals 5 squared. And I would take 25 minus 9, so x squared is 16, and then I'd square root both sides, so x is 4. So the distance from x to b is 4, so that means the distance from A to B would have to be 8. Those are the kinds of problems that you're going to see in your homework today, and your homework is as follows.